why is math not the language of physics, which is the title of the presentation today? Okay, math is not the language of physics. And first of all, let's clarify that math is a language. Okay, so it's not a science. Math is not science. And science is about explaining. What did I just say? Science is rational explanations, and there's only two branches, main branches: physics and philosophy. Physics, causes and purposes, causes and mechanisms, and philosophy is purposes and reasons. Okay, that's what we explain. So philosophy is a branch of science, and so is physics. And you don't see math in there anywhere. And so does math fall under physics or under philosophy? Well, does Chinese, the language, does that fall under physics or under philosophy? Well, Chinese is a language. It's not a science. And same thing goes to math. Math has all these fancy symbols, and they represent relations. So math is not, it doesn't fall under physics or philosophy, because science is about explaining and mathematics only describes. It has no power to explain. And it describes using these symbols that represent relations. Okay, so math is not even a part of science, let alone out of physics, which is a branch of science. Okay, so let's hear it from the horse's mouth here. We have one fellow, his name is Matt O'Dowd, and he works for PBS. He's got a show called Space Time, and there he tries to peddle the mathematical physics side of what they call science, physics, okay? And what it is just a bunch of nonsense. Okay, here it is. Okay, he says, the following says, quantum fields have no subjective qualities and have questionable physicality. In other words, there's nothing physical about quantum fields. And people don't always understand that because they think field is a physical object. No, it's not. Okay, and he's telling you, it's got questionable physicality. Absolutely not. It has no physicality whatsoever. Physical means object, thing. And fields are not things. Okay, field is a noun only for the purposes of ordinary speech, not of science. And he continues, says, they seem to be completely describable by only numbers. Right, because it's describe and it's only numbers. What are numbers? Verbs. Number is the verb to count. Okay, so yeah, all they can do is describe, and they're using these numbers to describe them. And their behavior precisely defined by equations. What's an equation? Again, it's a concept. Okay, it's a relation. That's all it is. Okay. In a sense, the quantum world is made of math. I love that. Yeah, because the quantum world might be made of math, but nothing in physics is made of math. Nothing in science is made of math. Okay. And so let's distinguish math from science. So does that mean the universe is made of math too? Only because what? Because the quantum world is made of math, and general relativity is made of math, and string theory is made of math. Okay? If you believe the mathematical universe hypothesis, then yes, and so are you. So you're made of math. Okay? I thought you were made of atoms. I thought you were made of cells, molecules, and it turns out you're made of math. That's the way they look at it. Why? Because that's the only thing that's of interest to a mathematician. They call it physics, and what they're talking about is math. So where did Matt O'Dowd get all this stuff from, And we can trace it to this fellow named Mark Tegmark. He came up with this notion. It's a chart, essentially. And what is it? He's saying that, just an example here. He says you have a culture. Okay, you have people out there who socialize, etc. And you can say that's sociology, okay? And where does that come from? Well, it comes from the mind, people thinking, okay? And so they end up with this culture. But where does the mind come from? Where does all this thinking, or what is the substrate for it? Well, it's the brain, okay? The brain is what what essentially causes mind to happen. Okay, all these fields that are in there, all this magnetic fields, maybe some chemical reactions, right? And what is the brain? The brain is cells, and you can say that's biology. What are cells? Well, they're made out of molecules. You can say that's chemistry. And what are molecules made of? Well, they're made of atoms. And so we go down the line, and what Mark Tegmark suggests is that eventually you end up with more and more quantitative math stuff, and you started off with qualitative, language stuff, So you go from more language to this world of math, and you end up with what they hope, what their holy grail, which is this theory of everything, which is the mathematical universe. Okay, so that's why they say that everything is made out of math, including you. Okay, so that's in a nutshell what these people are thinking. They say that physics is all about math because we're getting down into this rabbit hole, right, where it's ever more quantitative, right? But that's because they took it down there. It's the mathematicians who took it down to math, that say that science is all about math, physics is all about math. It's them. It's not that anybody else. I mean, the Greeks, they thought they wanted to answer the question of, how does this universe work in a qualitative way? And that was lost in the 17th century, okay, when they did the so-called 17th century revolution, right? Okay, so here's this fellow. His name is Leo Susskind, and I think Susskind or Susskind. Anyways, he's from Stanford, so-called physicist, actually mathematical physicist. And what does he say? Well, he says that you and I evolved in a world of 3 dimensions. We can't visualize more dimensions. I can visualize 3 dimensions in my head, but I use X, Y, and Z to describe them mathematically. Now I go to 4 dimensions or 5 dimensions. I can't visualize them anymore. I can't say now, close your eyes and view in your head 5 dimensions, because I can't do it either. So we're stuck needing mathematics because evolution didn't equip us to be able to visualize quantum mechanics. Okay? It didn't equip us to visualize 11-dimensional space-times. Evolution did this to us. So yeah, these people are talking about math, and they're trying to visualize something which is qualitative, like anything that is 3-dimensional, and that's qualitative. That has to do with physics, right? If it's got 3 dimensions, hopefully it's an object, it's a thing, and they don't realize it. They want to quantify it. They want to talk about numbers. That's the whole issue. And so the question is, what are these people talking about? Are they talking about math, or are they talking about physics? Okay, so which is it? And here we have another Nobel Prize winner. I talked about him a little while ago, and here it is. He's Steven Weinberg. He died a couple years ago. Says, I don't think mathematics can ever be regarded as an explanation in itself for anything. And this has not always been well understood. And why isn't he straightforward? Why is he, piddling around, saying, well, I don't think it can be, maybe, perhaps. No. It's very straightforward. Mathematics cannot explain anything. Mathematics is not an explanatory language. Only describes, it has no power at all to explain. And people don't understand that, including him. Okay? So yeah, the issue is that math does not explain anything. That's why we have no explanation. When they give you an explanation, the mathematicians, they give you a bogus explanation. They say, well, space is warped and time is warped and Big Bang happened, creationism. And they give you all this nonsense, black hole singularity, there's nothing there, but it swallows everything in because it's got infinite mass and who knows what else. And when you call their bluff and you say what you just said is nonsense, the guy says, well, that's not important anyways because that's not in our line of business. It's not in our line of work. We don't do that. So the question is, why did you try to do it anyways if it's not in your line of work? If you're not an expert in this stuff, why did you attempt to do this? I mean, it would have been much easier just to keep your mouth shut and say, I'm going to do math. Okay, fine, do math. But don't tell me that you're going to climb over the fence and tell me how physics works. You have no authority to do so. Okay, so here's one fellow that tells us clearly. Okay, he says, Donald Simonek, a university professor in Pennsylvania, science doesn't explain, science describes. Why does he say that? Well, because math only describes, and they equate physics, meaning science, right, with math. That's the whole issue. Okay, so yeah, if this is your starting point, if you already made up your mind that physics or science, which they kind of equate each other, right? They say, is only numbers, is only math, then yeah, then your conclusion is that science or physics only describes. And here we have a site, says Encyclopedia Britannica, says, during the 16th and 17th century, scientific thought underwent a revolution. A new view of nature emerged, replacing the Greek view that had dominated science for almost 2,000 years. So this lasted 2,000 years. Why? Because everybody just followed the Greeks. Whatever the Greeks thought was right, meaning Aristotle, people just memorized that and just repeated it. Okay? And so what happened? What happened was that in the 17th century, things changed. Science became an autonomous discipline distinct from both philosophy and technology, and it came to be regarded as having utilitarian goals. Okay, by the end of this period, it may not be too much to say that science had replaced Christianity as the focal point of European civilization. Out of the ferment of the Renaissance and Reformation, there arose a new view of science, bringing about the following transformations: the re-education of common sense in favor of abstract reasoning. Well, yeah, I think they lost common sense and they just went into abstract reasoning, especially when they got into the 20th century and started doing quantum mechanics and general relativity. It was abstract reasoning, but they forget to say that it's irrational abstract reasoning. The substitution of a quantitative for a qualitative view of nature. Exactly. You know, they replaced explanations with descriptions, with mathematical descriptions. The view of nature as a machine rather than as an organism. The development of an experimental method that sought definite answers to certain limited questions couched in the framework of specific theories. The acceptance of new criteria for explanation, not really, because they haven't had any explanation whatsoever, or you could say the new criteria was irrational explanations, and they accepted those, stressing the how rather than the why. The how meaning description rather than the why meaning explanation. That's what happened. Math can only describe. That had characterized the Aristotelian search for final causes. Okay, so what was it? The issue was that they went into mathematics descriptions. Why? Because they started doing experiments and they said, look, what Plato and Aristotle were doing, you know, that's not good enough for us. What we are doing now is doing experiments, and through experiments, we're going to get some objective data. What was the objective data? The objective data was measurement. They would measure something, weigh it or whatever, or distance or time. And once they got that measurement, right, they turned it into some kind of equation, into numbers. That's how we went. So it was experiment, math, experiment, math, experiment, math. That's what happened starting in the 17th century. And they forgot all about the purpose of physics to begin with, which was defined, by the way, by Aristotle. Okay, purpose of physics, what is it? To explain how this universe works. They forgot all about that. They say, who was it? Richard Feynman, he said, you know, we've abandoned all that stuff. We don't explain anymore. All we do is math and descriptions, because that's objective, they say. Whereas explanations, you know, that's opinion, and so we gave it to the philosophers. That's what happened here. Okay, that was the revolution that really happened. And unless you're in tune with that, you don't really know what's going on in the world today. Okay, here we have good old Toth there, and he defines each one of these. This is out of the Wikipedia. Mathematics is an area of knowledge that includes the topics of numbers, formulas, and related structures. Structures, I like the fact that they use the word structure. It's so misleading because it suggests that they're talking about objects when they are not. shapes and the spaces in which they are contained. Now, math doesn't deal with shape at all. Okay, and quantities and their changes. Yeah, quantities and changes. Yeah. There is no general consensus among the mathematicians about a common definition for their academic discipline. Yeah, it's not an academic discipline. Maybe that's why the mathematicians are all, in disagreement. It's a language. It's just a language. It's not has nothing to do with a discipline, meaning science. What is physics? The natural science of matter involving the study of matter. Okay, yeah, we don't study in physics, in science. What we do is explain, not study. Anybody can study without explaining anything. Okay, and its fundamental constituents, its motion and behavior through space and time, and the related entities of what? Energy and force. So what are they talking about? They're talking about space, meaning they think of space as 3D. What they really mean is they're going to put a set of coordinates, meaning not coordinates or dimensions. They're talking about number lines. So space, they think of number lines. Time, another number line. What's energy? A concept, dynamic, mathematical concept. What's force? Dynamic, mathematical concept. So no, physics doesn't deal with any of these. It deals with space only because it's the background to objects. Otherwise, it doesn't deal with time, energy, or force. These are concepts, mathematical concepts, and physics doesn't deal with that at all. Mathematical physics, what is that then? We got math and we got physics. Now we put them together and we get this mathematical physics. Refers to the development of mathematical methods for application to problems in physics. Problems meaning equations, meaning numbers, meaning units. That's what they're talking about. They're talking about doing, solving problems, mathematical problems. That's what they're talking about. They're not talking about physics. They're talking about describing mathematically and solving problems. What are problems? Relations. So you're trying to solve from a numerical point of view, quantitative point of view, something about these relations. That's all it is. Okay, so we call this, us here at this place, this channel, we call it the mathematical method. Why? Because this is what we've inherited from the 17th century. And what is it? It's a method of research and persuasion. They're talking about convincing you, persuading you to believe something that is true. They say, we're going to prove things to you, meaning we're going to try to twist your arm until you convert and we recruit you to our congregation. That's what it's all about. So they start with observation. Well, observation, to observe, what is that? They just said a minute ago, I said, you can't observe the electron. I didn't say it. Other people said it, that you can't observe an electron. Why? Because it's zero-dimensional, defined as such. It's an elementary fundamental particle. There's nothing there. It's 0D, zero radius, no shape. What are you talking about? You're talking about nothing. That's what you're talking about. So how can you observe nothing? What do you mean by observe? And besides, even if that were the case in science, we do not observe. We do not gawk. That's the issue. Explain tentatively, which they never do because the explanation is always bogus. Okay, what they're really talking about, they call it a hypothesis. It's not. Explanation is a theory. Okay, predict. We don't do prediction. No astrologers, no palm readers in science. So I don't know what this predict is about. Obviously, they're talking about math. They say, if the lion is running at, 40 miles per hour, it's going to catch the deer. Why? Because in so many seconds, it's going to be at such and such place if it runs in a straight line. So they can predict things, and they say, I can predict if the lion's going to catch it. That's what they're talking about. What's that got to do with science? Experiment, they do a lot of experiments, and they get equations out of that, measurement and equation, right? They describe mathematically, again, equation. Invent technology to confirm the theory, because they think that technology is proof of the theory. They say GPS confirms general relativity, and computers prove quantum mechanics. What's that? Technology confirming physics, or their equations, or their theories, right? That's the way they look at it. They convince other mathematicians, other colleagues, right? Called proof, truth, fact, knowledge. Those are the words they use. They verify the measurement, what is called falsification. Someone else verifies your measurement. If they verify it, you win a prize, maybe the Nobel Prize, and you walk the celebrity circuit. Now you have authority to trash anyone on earth because you have this gold medal in your hand. Right. So that's called science, according to these people. Okay, fine. So how do we compare it against ours? This is a rational scientific method. We call it the rational science. It's really the scientific method that we should have always had. Okay. We start with a hypothesis, okay, and we have the object's definitions, the initial scene, okay, and then we have the theory, the mechanisms and causes that are founded upon that, okay. So you can see the difference between the mathematical method and the scientific method. Okay, so where does this take us? Well, we're just going to give an example here today. We have gravity, right? Everybody knows about gravity, I think, and we've probably known gravity for as long as we've been around. Here's the only experiment you ever need to do in science, in physics, right? For gravity, you let go of the pencil and it falls to the floor. Always falls downwards, never upwards. It always falls to the floor, never to the ceiling. Always to the ground, never to the sky. Okay, so there we have it. Now we have to explain it. Okay, do we need a number to explain that? Do we need to know how fast it went? Absolutely not. It's a qualitative question. And then the question is that a question of physics? Is that a question of science? And a lot of people out there, especially the mathematicians, will say, no, that's not. That's not what we do. We do equations. We do measurements. We do units, numbers. That's what we do. But it turns out that people ask these questions. You go to Quora, right, which is a question and answer site. And people ask these questions, say, how does gravity work? How does magnetism work? What is electricity, etc.? Who are the people who answer these questions? Well, most of them are physicists, or they sign as physicists. Or they're students of physics, or PhDs, or getting they're graduating in physics. They're all into physics. Well, so it appears that this question belongs to physics because so many physicists attempt to answer it. And yet when you corner these guys and put them against the wall and say, call their bluff and say, hey, you're saying that you are physicists? Okay, answer the question. What is gravity? And they say, well, it's warp space or warp time. Warp time? That sounds like nonsense. Yeah, it is, but we don't care because it's not in our line of business. The philosophers do that because that's opinion. So why did these people attempt to do that if it's not in their job description? That's the question. Okay, so we got a problem here because these people are answering the question. They're giving you their peace of mind. They're saying, I can tell you what gravity is. Oh, what is it? Well, it's warp time. And you say, that's irrational. Yeah, we know, and we don't care because it's not in our line of business. So we go around in circles with these people. If they have nothing to do with physical interpretations, why did they even attempt to give a physical interpretation to a question of physics? If they're going to do math, stay in the realm of math. Don't jump the fence into physics. That's the issue today, really. Okay, so here we have what is gravity? This is how general relativity or mathematical physics in general answers. Says it's warp time. Those lines that you see there, white lines, all those lines, those are coordinates, what they call coordinates. Those are really number lines. And they have these number lines, which is a mathematical concept. As you can see, they're warped because there's a depression there caused by the Earth. And the moon has no other choice but to roll around the Earth because this has this wall of time, of curved time, that does not allow it to leave the solar system. That's the explanation. And again, when you tell them this to say, hey, that's an irrational explanation, they say, well, we don't care about that because that's not, our job, in our job description. It's not, our line of work. So why did they attempt it? Why did they do that? Why do they give you a bogus explanation and tell you that, yeah, they don't understand it either, and it doesn't matter anyways because it's not part of physics, because physics is just math. That's a whole argument there. Okay, and so they even throw in and laugh at you. They say, oh, people pay attention to warp space, to the warp canvas. So this fellow says, teacher, right, says, understanding gravity, space-time is like a rubber sheet. Massive objects distort the sheet and, wait, they distort it because they're pulled down by what? And the teacher said, oh my God, space-time is like this set of equations for which any analogy must be an approximation. No, it's not an approximation because approximation has nothing to do with the question that we're asking. We're saying, what is gravity? This guy tells us that it's a rubber sheet. And then they say, don't take the analogy so literally. And no, it's when they make fun of you by putting this cartoon in there, they say that the student says, oh, that's so boring. No, it's called irrational, not boring. Okay, so use the correct word. That's irrational, what they're saying. When they say it's not in our line of business, then you say, why did you attempt to give me this bogus explanation for how gravity works? That's the bottom line. Okay, so let's go with an example here, just to put it in the right context. What is the problem here? What's a qualitative problem? They say, we don't know what gravity is. You'll find this in core also. A lot of the people who answer say, we have no idea what gravity is. We're still researching. Someday we'll figure it out. Okay, so this is the party line. This is what they tell you. This is what they say. Fine. Okay, let's give an example here. Okay, here we have good old Casimir, my good old buddy there, and he's pulling on a donkey. Okay, and so we say, okay, you're there with your wife or your girlfriend. Okay, and you say, well, how did this happen? Okay, and how did the donkey go from A to B? Okay, and so person says, or your wife or whoever's next door to you says, well, very simple. Here we have this fellow, this farmer, and he's pulling on a rope, and which is tied to the neck of the donkey, and the donkey is pulled forward. It's straightforward. I mean, there's just by watching this, you can understand, right? In this case, right, why the donkey's moving from A to B, because being pulled by a rope. Everything is visible there. The farmer, the donkey, and the rope. Everything. So it's so easy. There's no mystery here. Okay. So what's the issue? The issue is here you have the general relativity version or mathematical physics version. They say the reason they came together is because they slide on a ball, because you have this warp space-time in the vicinity, right? Warp time, and so that's why they fall towards each other. And of course, nobody knows why they fall downwards. Why don't they fall upwards in the bowl? But that's never answered. They say things always come down. Fine. Okay, so what's the issue? The issue really with the whole issue here is the following. What if we make a change in our scenario? Instead of having the farmer with a rope tied around the donkey's neck and pulling on it, right? We're going to have the farmer just going like this because you can't see the rope. The rope is invisible, or you can't see it because you're too far or whatever. You don't see the rope. All you see the farmer going like this and the donkey coming towards you. And here, let me illustrate that. Here it is. Okay, you see that. And now the question, now you ask your wife or your girlfriend, you say, well, how did that happen? How is it that the donkey is coming towards the farmer? And you say, well, I don't know. I have no idea. And if you compare them, the only difference between these two, right, here is the other one, is that you can see the rope here and you cannot see it here. So the only issue here is that in one case you can see the rope, and in the other you cannot. And so the question here is that maybe there is a rope there. It's just a question that you can't see it for whatever reason. Maybe you're too far. Maybe your eyesight is not good. You don't have 20/20 vision. Maybe it's it has a color that blends in with the background. Maybe you got the sky there in the background, blue sky, and you have a blue rope. I don't know. And so you can't see the rope. And just because you can't see the rope, suddenly, it's an unsolvable problem. Here you can see the rope, and here you cannot see the rope. And the only difference there was, seeing, subjectivity, not what is there. Because what is there, if there is a rope there, it's just that you cannot see it. Objectively, what's coming out of the scene is that there is a rope, okay? Subjectively, you understanding or visualizing or touching or whatever, you cannot, see the rope. Okay, so the issue is that. And here we have the same issue with a pencil. If I could show you all the particles that are pushing it or all the ropes, in our case, that are pulling it, then you would say, that's no big deal. I understand that. That's kid stuff. The ropes are pulling. Why? Because every atom of the pencil is tied to every atom of the earth. So the closer it gets, the wider they go. You understand the mechanism. But only because I made the ropes visible for you. But if you cannot see the ropes and you cannot touch them, you cannot see the particles that are pushing, if that's your theory, right? Because of that, you say, well, I don't understand how that's done, how Mother Nature does this magic trick. Only because you can't see it. And what's the problem there? Well, the problem there regarding our subject matter today is that math doesn't deal with object, with things. So math is not in the business of looking for the mediators, the physical mediators. That's the whole issue. See, so math, the mathematicians, they call themselves physicists, but they don't do physics because physics starts with objects. You need to have an object. And these people don't start at objects. They start at new numbers, quantities, measurement, experiments, right? Predictions, observation. And they're not doing what they're supposed to do, which is look at the objects, the mediators. And hopefully, this magic trick, right? The pencil falling. Hopefully, the pencil is being touched by something. It's either touched by something that pulls it or it's something that pushes it. But hopefully something is coming in contact with a pencil, because otherwise you're doing action at a distance. And action at a distance is black magic. It's witchcraft. That's what it's called. It's the action at a distance is the scientific term for witchcraft, okay? That's what mathematicians do. They do action at a distance because they don't care about the physical interpretation, and then they just look at quantities and saying, this is how fast this thing is coming. This is how much mass it has. This is what the distance was. This is how much time it took. They're looking at all these parameters which they measure, and they try to give you an equation to describe what's happening, but they cannot explain because they're not in the business of explaining, and they never will. Therefore, they'll never figure out what gravity is. Because gravity, if we want to know how this universe runs, we need to look at qualitative stuff, and those are the questions people ask. They want to know how gravity works, meaning why, what causes it to work the way it does work. And those are the questions you'll see in places like Quora. They're all answered by physicists. The physicist says, this is what it is. It's all irrational. They say, well, we know it's irrational. We don't understand it either. And anyways, it's not in our job description. It's not in our line of work. Then why in the world did you attempt to give me a bogus answer?